All right, so I got a pretty crude setup here, but what I want to kind of show is the capabilities of this new relay that I have. It's called an induction memory cell, basically a smart relay, and it's this little device right here. And as far as the size comparison, this is your typical 12-volt relay, a mechanical, so obviously it wears out over time. This is a solid state relay, so it does not have any moving parts. And I want to show some of the features that this particular relay has in terms of like the different ways that it can be controlled. So there's three ways. One is by controlling it, just turning the power off and on. That can turn this relay off. And as of right now, this relay is connected to this fan, and this fan is connected to a 110-volt wall outlet. And it's and this relay kind of acts as a closes the circuit to turn this fan on. So first, I'm going to show the first way to turn this relay on is by just powering it on. So I'm gonna, and right now the power consumption is pretty low. This relay runs off of about 0.75 volts. There's other relays that normally on solid state relays on the market needs about 3 volts, a little bit less than 3 volts, but pretty close to 3 volts, and it doesn't work. And this relay operates at 0.75 volts. I'm gonna go ahead and power it on. And as you can see, when the relay gets power, it has a little LED line on it, and this fan turns on. So now I want to be able to show all the different ways that this fan, this relay can control this fan. So one way, as I already showed you, by turning the power off and on, you can control the fan. So if I terminate the power, the fan stops. And this is all doing this off of 0.75 volts. So the voltage and the power consumption is pretty low. So it's about 0.75 volts at about 0.05 amps. Now, when this unit is commanded off, because even though you can terminate the power by turning this relay off, you can also turn it off via laser light or infrared light. So I have a laser here, and I have a fiber optic cable that's connected to this relay, and I'm going to connect this laser to this fiber optic cable, and it's going to terminate the power to this relay, which is going to turn off the fan. So I'm connecting it now. Let's see if we can see that. And by this relay receiving laser light via a very, very long, this thing's about maybe 25 feet cable or something like this, pretty long fiber optic cable, and this fan turns off. And not only is it operating at 0.75 volts, but in the commanded off state, the current drops. So it's at 0.015 amps right now. That's all it's consuming right now in the commanded off state. And once you take the laser off the fiber optic cable, the relay turns back on. And that's one way to demonstrate to turn it off or command it off. But the other one, which is probably the most interesting, is this relay can be controlled via infrared light. So I have a lighter here, and I'm going to turn this flame on, and the infrared sensor is going to sense this fire, and it's going to terminate the power to this fan. So I'm going. As you can see, the fan turns off because the relay senses the infrared light or radiation coming from this flame. And if the flame goes off, the relay turns back on, and it turns the fan back on. So not only do you have a relay that's controlled by just terminating the power off and on, you can control it by exposing it to laser light via fiber optic cable, and you can turn it off. One of the safety features, if it senses infrared light from such a fire or something, it turns off, and it senses that flame, and turn it off, turns back on. So all of these capabilities, on direct connection on and off, fiber optic cable on and off, infrared light on and off, all add a voltage of 0.7 volts powering this. And this has a 110 volt 13 I think like maybe 13 amp triac inside of this unit. So this fan is connected to a triac, which is connected to the induction memory cell technology circuit that's inside of this relay, which is able to control this relay at such a low voltage input.